Hello everyone, good afternoon. So I'm Gaurav Goyal, I represent Fortinet and today I will be speaking on securing operational technology, IoTs and OT. So when we are discussing about smart railways, the railway is getting smart. We are converging our IT and OT network. We are using digital technologies. We are increasing the cyber physical surface. What about securing it? What about the security, right? So to start with, to start the context, what is OT? So we know IT. Whenever we click a button, I just clicked a button and then there is a dissemination of emails. We transmit messages, voice, videos. This is information technology. But what is OT, right? So when we click a button and it results in a physical action, activation on actuator. It can be a brake actuator, a line actuator on railways, railway track, right? So where do we find the OT? With respect to perspective of railways, we find OT on our locomotives, on our track side, way side, on stations. These can be escalators. So OT is present in different environment when it comes to railway. Now this operational environment was automated by industrial control systems, which were insecure by design. There was no security. There was no authentication inbuilt in the industrial control system. So how they were protected? The only security strategy that was employed was air gap. OT environment was operating in silos and it was not connected to the external environment, and this is how the OT environment was protected. Now what is happening? We need connectivity for growth. Similarly, in order to move towards digitalization, we have to bridge that gap. We have to converge. The IT and OT are converging. We are integrating our business zones with our operational zones. And with this connectivity, what we are doing, we are basically exposing our OT environment to those cyber attacks earlier which were applicable to IT. Now the OT environment is equally prone to cyber attacks which were prior to applicable to IT. So this is where the railways were, and this is how the present railway system is. That is, railway is not only moving, it's not only an important sector, but it's a critical infrastructure sector nowadays. And there are a lot of developments which are happening. The train is, a smart train with digital technologies on board for, the digital analytics and real-time updates. The passenger experience is getting better. We are having, faster updates, real-time updates, and accurate updates as compared to the previous ecosystem. But then there are ramifications. If we are not securing our OT environment from these cyber attacks, then it is getting exposed. And if it is not secure, there can be ramifications like, unavailability of the services, disruptions, bad customer experience, or it can be as bad as accidents. I have just plotted the cyber attacks on the OT infrastructure over a timeline to indicate that these attacks, which was started, uh, since 2010 on the Iranian nuclear sector, they are becoming more frequent. They are getting more sophisticated, and the reason is the motive. There is a whole industry. There are the nations, working. There are threat actors. They are motivated. And while trying to design a policy or strategy in order to secure the IT and OT environment, what we have to do, we have to learn, we have to follow the standards and guidelines, we have to see the future trends, and we have to learn from the past. And the history and the trend says that the railway sector is again, it's one of the target for the cyber adversaries. So it's high time that this OT environment has to be protected from the cyber security perspective. So I will walk you through the framework. These are the frameworks which are global frameworks which are applicable on the railway industry. On the left, we have TS 2701, which is applicable. It's a comprehensive guideline for IT. Since IT environment and OT environment, the natures are different, so there is a requirement of separate guidelines and standards or frameworks for OT environment. We have NIST CSF, Cybersecurity Framework for OT, and similarly IEC 62443, These two frameworks provide guidelines for protecting the OT environment, and they are applicable on industrial automation control system. There is a specific guideline, TS 50701. So it's a technical specification. It's applicable for railways. TS 50701 is derived from IEC 62443 specifically for the railway sector, and it controls all the aspects: signaling, controls, wayside, trackside, locos, stations with respect to OT cybersecurity. There are other specific guidelines for different regions and countries. So I will be walking you through the 4 use cases which are applicable for OT cybersecurity. So before to that, I have plotted here Purdue model, which is again given by ISA, that the environment can be divided into 2 parts. There is a red dotted line. On top of that, on north, we have the IT environment, business zone. And below to that, there is the OT environment, where we have actuators, sensors, SCADA system, HMIs, historians, security management systems. So IEC 62443 says that there has to be segmentation, there has to be zones and conduits. The equipments, the devices which are supposed to have one security level should be in one zone, and whenever there is a communication between 2 zones, it has to follow through unique access point. This unique access point should be capable of high performance, high availability, ease of use. It should be rugged because it has to operate in special environmental conditions. OT is not in the air conditioned environment always. It is there in the field. It might be on the loco, it might be on the track side or wayside. Then this unique access point should understand the OT protocol languages, because when we speak IT, it's a different protocols. But with respect to OT, these protocols can be Modbus, IEC 101, 104, when we are communicating with the electrical substation systems. And it should be capable of handling advanced persistent threats and should be able to take care of the known vulnerabilities. So IEC 62443 not only says about zones and conduits, it also covers cloud security, automated SOC, NOC, advanced persistent threats, application control, IPS, IDS. Here I have plotted a typical architecture, and this is a basis of TS 50701, which is the framework applicable for railways. Here I have divided the architecture into 6 major SUCs, subject under consideration. On the top we have business zone, and below there are 4 zones. On the left there is a train which you have automatic train protection, and then passenger information system. Then we have wayside, trackside, which is divided into 2 parts. On the top we have HMI and train supervision system, and below we have sensors and actuators for signaling and CCTV. Then we have another SUC for the station, again which is divided into 2 parts, the HMIs and the BMS system on top, and the PEAS, voice and escalators below. Then the next SUC is electrical substation for the power, again which is divided into 2 parts. And there is one more SUC which is for remote employees, contractors, vendors, which are connecting to these SUCs remotely. So how they are interacting, these SUCs are interacting with the operation center, and there are remote interactions. Now if we put the Purdue model, if we put the IEC 62443 guideline on this, in order to implement zones and conduits, we have to, all the communication between SUCs have to be driven through the firewalls, next generation firewalls, so that they can understand the OT protocol, they can set the firewall policies, and the traffic can be monitored and controlled and secured. The communication through remote access is secured through ZTNA or SSL VPN, two-factor authentication, multi-factor authentication, thus bringing the security in the secure remote access. Communication between SUCs, the intra-communication between SUCs is normally happens on exception. It has to be validated by CISO. Again, there has to be logging and reporting, but then it is again managed by the firewalls. And between the SUC, any communication between the 2 zones of the SUC, we have internal segmentation firewall. So the previous use case was explaining or is a solution to control or to provide security for the known threats. What about the zero-day OT threats? The threats which are not, the signatures are not available in the market yet. So we have advanced persistent threat solutions sandboxing, where we have a virtual environment. There is a APT tool. Whenever there is a malicious file or OT protocol file, it will be detonated by this environment in a zone outside SUCs in the different OT environments so that it can be studied. And if it found malicious, it will not only, it will not only block the malicious file, but it will also share the threat intel with the other firewalls which are deployed in the region. That means this sandboxing will take care of the, the zero-day OT attacks and detonate in a virtual zone away from SUCs and take care of the, also, bringing the intelligence to the other sensors which are there. Secure networking. So we do have this is the third use case of SD-WAN, where we do have next generation firewalls with SD-WAN capabilities which have OT native security. So that means in this use case, there is a connectivity between business zone and the stations through SD-WAN. So we can do traffic optimization. We can also set firewall. We can set policies to prioritize OT traffic, which is related to train rather than passenger information system. There is a use case on SIM and SOAR. We have automated SOC. So in this automated SOC, the SOC's SIM and SOAR can be deployed, can be used for IT as well as IT. It is IT as well as OT. It's a centralized system which is equally applicable for IT and OT. So when it comes to industry analyst, industry has recognized and validated Fortinet. There are more than 37 validations. When it comes to IT OT security solutions, we are recommended by Westland Advisory and Forresters as a strong leader and performer. So our solution is broad. We covers IT as well as OT. The solution which is offered by Fortinet, it covers the entire segment, IT as well as OT, and they are integrated. All the equipments are integrated and communicating with each other, and they are automated with the automated SIM and SOAR. And we do have OT specialized offerings. We have ruggedized solutions for firewalls. We have ruggedized switches. We have ruggedized access points. Then we have specialized threat information. So we have FortiGuard Labs, which is continuously working on updating the signatures, the OT protocol knowledges, which we are feeding in our firewall so that they can be more updated on the signatures and the vulnerabilities. We have a specialized talent there are people who are working with the industry consultants in Europe on TS 50701 to understand the framework, and also we are giving our inputs from OEM perspective. And we have a specialized ecosystem. We are in partnership with the technology partners. So these are some of the recommendations from as a OEM vendor, that what should be the next steps in order to understand the gaps, to access the gaps, and to secure those gaps. Thank you very much. If you have any question, I will be more than pleased to answer, or I will be here to take your questions later. Thank you.